Hey guys, it's me, Engineereya. In mathematics, there are two different methods to divide the polynomials. One is the long division method, another one is the synthetic division method. Among these two methods, the shortcut method to divide polynomials is the synthetic division method. It also called the polynomial division method of a special case when it is dividing by the linear factor. It replaces the long division method. In certain situations, you can find this method easier. In this video, we will discuss what is synthetic division method, how to perform this method, and steps with more solved examples. So let's start our discussion. First is, what is the synthetic division of polynomials? The synthetic division is a shortcut way of polynomial division, especially if we need to divide it by a linear factor. It is generally used to find out the zeros or roots of polynomials and not for the division of factors. The formal definition of synthetic division is given as: synthetic division can be defined as a simplified way of dividing a polynomial with another polynomial equation of degree 1, and is generally used to find the zeros of polynomials. The division method is performed manually with less effort of calculation than the long division method. Usually, a binomial term is used as divisor in this method, such as x minus b. Next is how to perform a synthetic division. To divide a polynomial using synthetic division, you should divide it with a linear expression whose leading coefficient must be 1. This type of division by a linear denominator is commonly known as division by Ruffini's rule or the paper and pencil computation. For the synthetic division method to be possible, the following requirements must be met. The divisor should be a linear factor. This means that the divisor should be an expression of degree 1. The leading coefficient of the divisor should also be 1. If the divisor coefficient is other than 1, the synthetic division process will get messed up. Therefore, you will be forced to manipulate the divisor to convert the leading coefficient to 1. For example, 4x minus 1 and 4x plus 9 would be x minus 1/4 and x plus 9/4 respectively. To perform polynomial synthetic division, here are the steps. Step 1. To set up the problem, first set the denominator equal to 0 to find the number to put in the division box. Next, make sure the numerator is written in descending order, and if any terms are missing, you must use a 0 to fill in the missing term. Finally, list only the coefficient in the division problem. Step 2. Once the problem is set up correctly, bring the leading coefficient or the first number straight down. Step 3. Multiply the number in the division box with the number you brought down and put the result in the next column. Step 4. Add the two numbers together and write the result in the bottom of the row. Step 5. Repeat step 3 and 4 until you reach the end of the problem. Step 6. Write the final answer. The final answer is made up of the numbers in the bottom rows with the last number being the remainder, and the remainder must be written as a fraction. The variable start up 1 power less than the original denominator and go down 1 with each term. Let's also discuss the advantages and disadvantages of synthetic division method. The advantages of using synthetic division method are: it requires only a few calculation steps. The calculation can be performed without variables. Unlike the polynomial long division method, this method is a less error-prone method. The only disadvantage of the synthetic division method is that this method is only applicable if the divisor of the polynomial expression is a linear factor. Now, let's proceed in the example. The example is: divide x cubed plus 5x squared minus 2x minus 24 by x minus 2. First, write down all the coefficients and put the 0 from x minus 2 is equal to 0. So, it will become x is equal to at the left. Next, bring down the 1 that indicates the leading coefficient. Multiply 1 by 2 and add the result to 5. The result is 7. Bring 7 down. Multiply 7 by 2 and add the result to negative 2. The result is 12. Bring 12 down. Finally, multiply 12 by 2 and add negative 24 to get the result to get 0. As you can see, the remainder is 0. So the answer or the quotient is x squared plus 7x plus 12. Let's have another example. The next example is 3x cubed minus 2x squared plus 3x minus 4 by x minus 3 using synthetic division. First, write down all the coefficients and put the 0 from x minus 3 is equal to 0. So it will become x is equal to 3 at the left. Next, bring down the 3 that indicates the leading coefficient. Multiply the number in the division box with the number you brought down and put the result in the next column. Add the two numbers together and write the result in the bottom of the row. Repeat step 3 and 4 until you reach the end of the problem. As you can see, the remainder is 68. Since we started with a polynomial of degree 3 and then divided by x minus 3, that is by a polynomial of degree 1, I am left with the polynomial of degree 2, then the bottom line represents the polynomial 3x squared plus 7x plus 24 with a remainder of 68. Putting this result into the required mixed number format, I get the answer as being 3x squared plus 7x plus 24 plus 68 over x minus 3. Let's have another example. The next example is 4x cubed minus 8x squared minus x plus 5 all over 2x minus 1. In this example, you will be the one to answer it. I just want to know if you have learned about this topic. If you have your answer, you can message me through my Facebook page to check if you got the correct answer. Before we end, please do support my YouTube channel by clicking the subscribe button and also click the notification bell for more update videos. This is the end of our topic for today. I hope you guys learned something new about this topic. If you have any questions about this topic, just comment down below or message me through my Facebook page and I'll try my best to answer it. Thank you for watching it. Bye!